like what they make, kind of like.
Look on somebody else's notes right now. I want you guys to look them up. Look them up. Look on somebody else's notes. Because I'm checking homework. You can probably start on the other side if you can't do that side right now. Alright, I'm swooping around super fast. You're wonderful. I'll come back to you. 15? Alright, if you've got more time, I'm sure you've got other parts of the puzzle to accomplish. You're not just sitting there chilling. I shouldn't have to tell you to do something. You can't go for it. I'll be right back. I'm not gonna wait. Yes, please. Like you said, N. Alright guys, take like another minute, whatever you're working on. Thank you for those of you who took the time to look through your notes for the answers on how to predict these products. I saw some weird stuff, and usually when I see really weird stuff, it makes me think that you did not actually try on that. So if you did not react with oxygen for combustion problems, you didn't try. You didn't even go back and look at your notes. So you have to react with oxygen. Secondly, if you know that you have a hydrocarbon, hydrocarbons always make what for combustion whenever they react with oxygen? CO2, H2O. It's not a secret. It's a standard. There's no other way. So then from there you would have to balance. So you need to remember those. Those are the two easy, I think, the easier ones for combustion, because you just remember combustion always reacts with oxygen, and hydrocarbons always make CO2 and water. That one's like just one thing out of the way you got to handle. So I want to review a couple of them because I thought that maybe you guys got the hang of it really well yesterday because we practiced quite a bit in class, but I think we need to review some of these. So going back to single, first one right here, tell me what you guys wrote. First one. And if you don't have it, then you better have it now, so we're going to go over it. zinc plus Pb, NO3, 2, and then you stopped and you said, what do I have to ask myself? Is zinc more active than lead? And so you looked on your list and what happened? It's a yes, right?
Why didn't you put the charge for zinc?
Because it's a good question. This is zinc solid. Zinc solid is just pure zinc. It can form zinc 2+ in a reaction, but it's not going to start off as zinc 2+. It can form it when it reacts with something else, but initially it is just solid zinc. So I'll even put solid there, and I'll put aqueous here to tell you it's a solution. Okay, so then you said zinc does react, and that's when you have to implement the 2+ charge. So zinc switches with lead to form what? Zinc nitrate with NO3, 2. That's when you implement the charge. Plus Pb. And again, Pb is solid here. Do you put the ion charge? No. Solids are pure solids. They're not charged. Ions are ions. They have charges. They're two totally different things. Solids, you'd actually see that lead fall out of solution. It'd be like a big lump of stuff on the bottom of the test tube. Lead 2 ion, can you see it? No, it's like itty bitty. It's an ion in solution. You cannot see it at all. So this is solid. Okay, then to balance it, it's balanced. Okay, how about this one down here? Barium is mixed with water. This is the part of the activity series I briefly mentioned yesterday, but we didn't talk about an example. Yes, ma'am?
So when we do some tests, we can take points off if we don't have it solid.
No, I won't take points off if you put a charge when it's not charged. Right. But I'm putting it there for clarity so you understand it's not an ion. Okay, so barium is mixed with water, so I know we know this much. Tell me, what does it make?
BaO. Barium oxide.
Look on your list first. First of all, on the activity series, is barium high enough? Or on the, I don't have a list in front of me. Yes, I do. Is barium able to replace hydrogen from cold water? Yes. I don't know if you. I'm going to hold mine up. At the very top of the activity series, it says replaces hydrogen from cold water. So when it says replaces hydrogen, what is barium switching with? Hydrogen. Okay. So I want to show you how to write water in a different way, so you can see it better. So instead of writing H2O, I want you to write H parentheses OH. HOH is just H2O, right? 2 H's and an O. It's the same thing, and you don't have to write it like this, but I'm trying to give you a tip on how to predict this product. So just because, previously we had like A plus B, C yields, blah, blah, blah. So all we did was like take A and B and we just switched them. Same story applies here. Barium can replace hydrogen from cold water. So if we switch them, what happens? What does it make? Okay, I'm going to write H, but we all know it's not H. H2, right. Hydrogen gas is involved here. So you would actually see that gas coming out of solution. Okay, and then what happens when barium and this guy gets together? Barium hydroxide, OH. Are we questioning ourselves in the two? Or we know it.
No, we know it.
We know it. It's like it's a 2 because barium's charged. Yeah.
Where did you get the extra oxygen, not oxygen, hydrogen.
I didn't get it from anywhere because I haven't balanced it yet. It's how the atoms rearrange. They rearrange in a way to make hydrogen gas, but we also have to combine these in a certain ratio, which is what we're getting ready to do. We have to balance it, and then you'll see where it came from. Yeah. Yeah. Let me finish this one real fast. So balancing this one, what do we need? So you see 2 hydrogens here, and you see 3 hydrogens here. I'm sorry, 4 hydrogens here. 3, 4. So what am I putting? Here. Okay, so that's going to make 4 hydrogens. This 2 also plus the oxygen to make 2 oxygens, yes? And that satisfies our 2 oxygen need. So for every 1 barium that reacts, it's going to use up 2 full water molecules, and when it reacts, it's going to produce 1 hydrogen gas molecule, and a barium hydroxide solid. This is solid. I know it's solid because look on the solubility rules. What does it say about hydroxides? Oh, and there's actually an exception to that rule. My bad. Hydroxides, it says hydroxides. This guy OH is insoluble, except for CBS, calcium, barium, and strontium. So this one actually will be aqueous. Just to let you know, you can look further into the solubility rules. They don't only apply to double replacement. They can apply to single, but I usually ask you to only do double replacement. Okay, I was asked to go over number 2. Aluminum is mixed with nickel 2 sulfate. So you write out the reaction first.
Yeah.
Twos are where? Where's my twos? Nickel 2 sulfate. SO4 is a 2, so we crisscross down to 1. Okay. Can aluminum replace nickel?
Yes.
Yes, because aluminum is higher, nickel is lower, so then what does it make? Al2, SO4, 3, because aluminum has a 3 charge. Nickel solid. Okay, so that did happen, and we need to balance by putting a 3 here, and a 2 here, and a 3 here. Okay, let's go over maybe 1 double, and then because I don't think you can mess up on double because you're just switching them. You switch both of them, so you don't even have to figure out does it happen. Yeah, oops, it will happen. So double replacement, I want to go over 1. Iron 3 nitrate mixed with potassium hydroxide. Go. Okay, and then who puts the pluses and minuses? Okay, well, I'm sorry, who, like, as in you people. I put the pluses and minuses just to verify we all know what's a cation and what's an anion. This whole thing over here, the polyatomic ion, don't be a home wrecker, right? We want to keep it together. It's going to get a negative. So it's going to make what? Iron 3 hydroxide and potassium nitrate. You guys are speaking my language. Awesome. Okay, so then we have 3 nitrates here. How many nitrates here? 1. So I need 3 here. 3 potassiums. 3 potassiums, and that gives me 3 hydroxides. I already got 3 hydroxides. I got 1 iron and 1 iron. So it's nice to consider polyatomics as an entity, one entity instead of going, I got 1 H and 1 O and 3 O's. Then it gets way too confusing. Because can you imagine trying to balance, like, I've got 10 oxygens on this side and then trying to figure out from there? It would just be more complex. So think about them in polyatomics if you have them. Okay, so when you do double replacement, what do you have to consider? Solubility rules, right? Okay, so what do we know? What do we know about hydroxides? They're insoluble. And is iron an exception? Nope, so guess what? That baby precipitates. What do we know about nitrates? All soluble, right? No exception, so we know it's aqueous. So what would this look like if this reaction happened? We put a liquid. This is a yellow liquid. And we put it together with this clear liquid. And then voila, we would make this solid that's probably like brownish yellow. That's it. We would see a reaction. So, you know our 5 evidences of chemical reactions? Precipitation, gas evolution, heat or cold, temperature change, Follow or change? Fire. Yeah, so there's a couple of other evidences, but those are the couple that we definitely know. So that would be a precipitate, and we would actually see a chemical reaction. Okay, oops, combustion, the bottom of the screen. Combustion. Let's go over, I'm starting down here. This has 5 carbons. What's the prefix for 5? Pent. This is pentane. Just FYI, that is pentane. Pentane is combusted. Okay? It's combusted with what? Oxygen. We have no choice, right? We also have no choice in this product. What are the products? CO2 and H2O. Combustions should be easy. Please do not just throw things and just like smush them together because you think that's how they react. Okay, so then what's our first step? Balance which one first? Now, oxygen would be harder to balance because you got it in 2 places. So I usually wait for that one for last. So let's start with
Water.
Oh, I was going to say carbons. Or hydrogens. Carbons or hydrogens, right? So what do I put here? And here? 6. Okay, then together I have how many? How many oxygens? Sorry, how many oxygens?
16.
So 5 times 2 is 10, plus 6. Yay, 16 is an even number! Put an 8 here, and then none of that doubling stuff. Okay, any more questions that I did not go over? Speak now for Coach Peace. Yeah. Number 1, iron 3 is combusted. I was hoping somebody would ask me one of these. Iron 3, how do I write iron 3? Fe. That's it. No, you do not write anything else. It's just iron. Why do I have to tell you iron's charge up front, though?
So you
Yeah, because when you start to crisscross it, you're like, oh my gosh, I don't know iron's charge. It's in low. But you know it reacts with oxygen, because that's what combustion is. Then it's basically synthesizing or oxidizing or combusting. It's all the same thing. It's just making one product here, which is Fe2O3. And in balance? A 4, I hear you. A 4, a 3, and a 2. Okay, this is rust. So this is like the oxidation of steel or iron. Steel has iron in it, and therefore we get rust, which is bad for our bridges and stuff like that. So that's a real life example and a balanced chemical equation. Yeah. I'm gonna wait on these. I'm gonna wait on this because you. So, okay, pull up a piece of paper. Pop quiz. No, I'm just joking.
We're doing a lab, is that okay? That's hard to spell, I'm sorry.
Okay. You're like, okay, so let me tell you a little bit about the lab and then I'm going to set you free, okay? Let's do this. This is called Types of Reactions Lab. So we're going to explore the types of reactions. Whenever we go through this, you'll see it says synthesis, decomp, single replacement, and double replacement. So what is missing? Combustion. So if it asks for you to label the type of reaction and you put combustion, you did not read. Got it? That's not one of the ones we're doing, supposedly. So, well, you might find some things that are similar, but underneath the procedures, it gives you very, very specific information about what to do. You need to follow it to the T. Do not mix chemicals that should not be mixed. Because I want to make sure that you see the results you should be seeing, because that's how I'm grading you, right? So I want to make sure you're seeing what I should be seeing too. So there's 4 parts to the lab. At the bottom, it says to make a data table. The data table is basically procedure 1 through 4. What does it look like before? What does it look like after? And then identifying the type of reaction and identifying the actual BCE for that reaction. It's very simple and it's very fun. But I'd like to get this done in about 45 minutes so we have time to go. Well, I didn't want to do notes first. I want to do notes at the end. Okay, we just have a couple of examples to go through. But I need to tell you first before how to do a couple of these steps.
Just turn around for me back here and I'll show you. Whenever you are filtering something, you're filtering because you want to capture solid from a liquid, right? You don't pour solids on the sink. So this is a filter paper. We've used it before. You basically make a bowl. So usually what I do is I take a fold it in half one way, half the other way. Hot dog hamburger, you know, our skills. And then you just make you fold it to make a bowl. It's not going to be pretty, but it's functional. Okay, it's a bowl. And that fits in this funnel perfectly. And
and that's how you filter out solids. The liquid comes through, solids stay here. That's what that we want to trash at the end. A second deal is that you have a flaming, this is a splint, this is a popsicle stick. It's going to ask for you to eventually make a flaming splint. It's going to be on fire. Yeah? This is going to burn. You should have a beaker of water out to put it out. Don't blow it out because you know it's going to cook it. Yeah, we don't want to have a fire drill. I don't want to do that. Okay, and also, whenever you have one of the experiments, it asks for you to hold a test tube at an angle. So, you see my imaginary test tube? Yeah? I'm putting it in there. I'll let it go, just squeezing it. I'm going to hold it at an angle, not on my partner's face, not on my face, but away. And then it says to insert the flaming splint inside the mouth of the test tube. It literally means catch the flaming splint on fire, hold it in the inside of the mouth of the test tube, not down here, just in the mouth of it, and see what happens. Okay? So, that's basically it. Lab groups. Ooh, I didn't make you lab groups. Can you get your own? 3 people per group. So, get your lab out now. Are you Five, 4, you need 5, 3, 2, it's called test reactions. Similar to not anymore. Alright, so you guys are sharing materials. Let me tell you what one more thing is that you guys want your lab station. Ready? Look this way now. This is the iron station. This is where you will map the iron filings. It says to get about a gram. I have radars here for you. Whenever you scoop it out, you're going to take your hand and tap it until it hits the 1 gram mark, whatever you need. Okay? This powder stuff is everywhere, so be careful. Okay? So I'm leaving it in one spot. Otherwise, I'm going to turn the gas on, so whenever you guys get that part, you can do it. Which is soon, so I'm going to turn the gas on now. No.